First, I'd like to thank Ms. Şinay Kemner to have invited me here. And it's a great pleasure to be here with you, with these distinguished guests. So the title of this panel session is Human Factor for Industry 4.0. The topic has already been gently discussed this morning and in the afternoon, but we'll go deeper here with our distinguished guests. And I'd like to just mention a few things about the topic. I'm coming from the university, and generally the industry have some requirements from the university. The first thing that the industry requires from the university is the qualified human resource, both at the undergraduate level and at the postgraduate level, education and research type. The other things, this is related to our panel session today, but the other ones are like consultancy, joint research, technology transfers. We'll not discuss them over here. But it seems that when we look at the human factor in Industry 4.0, it seems that the skills that are wanted seem to be interdisciplinary skills, critical thinking, creativity. These are the top skills that are required by Industry 4.0. This morning, our panel speakers mentioned about working together, particularly with IT people, changing roles in Industry 4.0, and it seems that the human factors should be a long-term strategy. So first, before starting, I would like to give some information about our distinguished speakers. First, I'll start with Professor Dr. Frank Lehmann, maybe in Turkish Frank Bey. Okay. He's a member of the board of Mercedes-Benz Türk A.S and director of the truck plant in Aksaray. After completing training as a mechanic, he studied mechanical engineering at RWTH Aachen. I looked what does it stand for RWTH, but it was very difficult for me to pronounce, so I will say RWTH. After receiving his engineering diploma, he joined WZL of RWTH Aachen in the field of manufacturing engineering. And he was responsible for research coordination in his field as chief engineer. After 2 years working as internal consultant for Tyson Handels Union, Professor Lehmann joined Daimler AG. He worked for 5 years in Evo Bus, the bus and coach division. He then took over responsibility for manufacturing engineering of the commercial vehicle division. In 2003, he held various positions in Mercedes trucks and Daimler trucks, particularly in Czech Republic. Since 2015, he has been plant manager in Aksaray, Turkey. Professor Lehmann, as his title indicates, he is also teaching manufacturing engineering of commercial vehicles at Technical University of Kaiserslautern since 2004. He also teaches at the Turkish-German University of Istanbul. Thanks for coming.
Thank you very much.
Mr. Ekrem Bulur, he was born in Turkey. He is Eskişehir, Turkey. Eskişehir is an important place today. Here, there are many people from Eskişehir. And he is currently the general manager and deputy chairman of board Magnesit A.S in Eskişehir. He did his high school studies in Turkey, but then he attended Technical University of Darmstadt and received his diploma in electrical engineering. He had a qualification as a German, Turkish, and Turkish-German translator from the Düsseldorf Commercial Chamber. His career life began in 1986, where he worked for a year as the head of assembly for the department of the railway engines for Tülomsaç. He then left for military service as a lieutenant for the Air Force in Kayseri, and then he went back to Tülomsaç as the head of assembly for the railway department again, and also took on the responsibility for the test stand and the locomotive factory. Welcome again.
Thank you.
First, we will start with a very general question, maybe with Professor Lehmann. How do you think Industry 4.0 is changing the future requirements of work qualifications and skills?
I think we have to separate let's say, the group of people we are talking about in separate, let's say, groups. One, we have to talk about the developers. So we've been talking about IT this morning, looking at our friend from Software AG. So that's one group. The second is the users. So the people who are interacting with the piece of software or with the systems. And I believe there's also a group of the ones who might be left behind by more automation. This is also a group which was addressed this morning. So, and maybe a fourth group is how do we set up our organizations? So like leadership skills and org charts of big companies, small companies, etc. So there are different topics. Starting with the users, maybe because he or she should be in the focus of what we are doing anyway. I believe that we have to overcome this old style IT development process of writing thick requirement definitions, 500 pages, programming for 3 years, and then coming back with something which was never asked for. And the world has changed anyway. So spending a lot of money with nothing real benefits. So that the process of making software or designing systems is more like a rapid prototyping, fast prototypes in practice, test them out and improve them in a very fast moving cycle. Very agile development. We're talking about swarms and Scrum, so there's a whole vocabulary which describes this. And I believe that this, the language people have to somehow master of describing what they want. It's something we have to train and to learn how to overcome this old style. This is the IT guy, this is the end user. So this is one thing. And through this, maybe this is also a requirement, is that we have to think in maybe smaller dimensions in improving things. It's not the large systems which make people believe that large investments in IT bring large benefits, but maybe it's the sum of small steps which bring fast improvements, small improvements, but incremental, but you can collect the money over due course of time. And this is something which we have to learn, to train our people. For example, what we do is we have a training center for blue-collar workers, those blue-collar and white-collar workers, but if you look at the blue-collar workers, and we've seen that over the years there's a shift from mechanical sort of training, like I received some decades ago, to mechatronics, to electronics, hydraulics, pneumatics, so more the system side of it. So I believe that these people are better trained to interact with the software developers than like I was trained in the past, something like this. So this is, I believe, very important for that group of people.
Thank you. Thanks, man. Mr. Bulur, would you like to comment on the question?
Okay, doctor. I must read it because my English is not very good. My German is very good. I must read it. My answer. In general, automation and intelligent tools, machines and technologies will advance, and the need of the skilled labor to perform manual tasks will decrease. All kinds of smart devices will provide the worker with the exact information they need in real time or in a certain station to perform their task efficiently. Integrated into the digital world of the factory, the workers are able to control and monitor production processes through the analysis of data and information supported with these devices. Intelligent assistance systems with optimized human-machine interfaces will further make it possible for the worker to make qualified decisions in a shorter time. Also, new kinds of machines will enter the workspace. Workers with robotics will be sensitive and intelligent enough to share a workstation with humans. The robots of the future are easily programmed and can be integrated into the production smoothly. Furthermore, different technologies will relieve the workers from very simple jobs, enabling them to focus on more qualified activities. In general, machines, robots, materials and other devices will advance and become so-called cyber-physical systems through the integration with cutting-edge information technologies. This revolution on the technological level will also affect the human in a way that the intelligent tools and technologies will become more autonomous. Nevertheless, the supervision and efficient application of machines by humans will become more important than ever before. The trends towards the station in a factor of the future can already be identified by some tools and technologies that are used today.
Coming from the higher education sector, I would like to ask first to Professor Lehmann, since he is seeing the both sides, both the university and the industry side. What do you think, what are the roles of higher education sectors, universities, vocational schools, etc., government and the industry to generate the necessary workforce training and development for Industry 4.0? In Turkey, in fact, the ministry calls it as digital transformation of the industry rather than Industry 4.0. I suppose Industry 4.0 is very popular in Germany, but in Turkey we have created this name as digital transformation.
We as Daimler call it also digital transformation. So it's because it embraces all processes in the company. It's not just industry, it's not just manufacturing, so it's better suited to describe it, I believe.
The roles of university, government, and the industry.
Let's start with the university. So as I grew up in an environment where it is absolutely standard that there is a very close cooperation between university institutes and companies, in the research field as well as in the consulting field. So the institute I spent some time did consulting work on how to improve ordering processes, complexity management, all that stuff. So things big consulting companies could also have done, but we did in that respect. So there was always a very good exchange of what are the problems in the industry and what can a university contribute to the benefit of the industry. So it serves both institutions. The industry benefits from having good ideas coming in, maybe out of the box ideas. Second is you get to learn some maybe good students from the university or good assistant professors who you might want to hire after the project. So, and there's no need to test them out because you already know them. They have already done a project with you. And the other way is that the students being taught by the professors get real industrial insights through examples out of industrial projects. So that the students, as soon as they have concluded their studies, are aware of what's going on outside of the university building, Yes. So it's not pure theory.
Yeah.
And so this is, and it kind of evolves like this, so that as you grow your cooperation, you grow into topics and things. So this is one thing, and of course what a government can do is to support this, to set up infrastructure, help setting up infrastructure, help setting up corporations, so that if two partners meet and want to make a project and they need a little support, some courage, to support things, that a government has a plan how to support this, particularly in small and medium-sized companies. I mean, we are a huge company, but usually this is clearly a fact for small companies who do not have the resources to support this kind of cooperation. And this is, I believe, something what a government can do, to regional government or national government, no matter what can be supported.
So we surely know that there are differences in the Turkish industry and the German industry in the global sense. So I'd like to ask first to Professor Lehmann, are there any differences in the needs of Germany and Turkey for the readiness of the workforce for this for the digital transformation. What do you think? I mean, would it be different in Germany, in Turkey? This preparation, work skill preparation. Mr. Bulur, do you see any differences?
Yes.
Turkey and Germany?
Also, quick answer is yes. Because we have different educational system from Germany for vocational training to supply the qualified human power. In Germany there is another system, dual system for vocational education. Our country, Turkey, has young population. This is the advantage according to the European Union. But we have to manage visually this power to increase our productivity with right educational system. Improved collaboration between industry and higher education or technical. These include existing one-side training, local trade centers, and community college or cooperative training with industry partners. We are a developing country. The third revolution of industry has been not fulfilled for us. Also, we have no time for this. But from today, industry technology or productivity will have to move up into level of Industry 4.0 under favor of qualified labor force. For this, we need lifelong training for workers on industry, revolution on vocational education system, and new government policy. Otherwise, our low labor costs, our productivity will not make sense according to developed countries.